All right, the last thing that you need to do is you have to be able to use an activity series. And the activity series tells us which elements are more reactive than the others. You're using these basically to figure out if a reaction is going to take place or not. And to do that, well, you got to have a reaction. So let me pull out the practice sheet so you can see what I'm talking about. You got to have a reaction. These are all single replacements because that's really where we use these activity series. What we need to be able to do is look at silver and potassium nitrate and figure out if a reaction is going to happen or not. And it comes down to where silver and potassium are on our activity series. Silver is down here towards the bottom, and potassium is up here towards the top. As you can see on the side, the more reactive ones are at top, the less reactive ones are at the bottom. So what this is telling us is that potassium is more reactive than silver. Potassium is more reactive than silver. Hold on, folks.
I need these teachers to go to Ms. Kill's class. It's Collins, Pelletier, Hannigan, Elliott, and Daniel to the guidance department. Thank you.
So this is what the series tells us. Potassium's higher up the list, that makes it more reactive. Silver's way down the list, that makes it less reactive. Now what we have to know is that the more reactive one wants to be in the compound. So if the more reactive one is on its own, the reaction will happen. It'll swap places with the less reactive one and you'll get a new element or compound. So if the more reactive one is on its own, the reaction happens. It'll take place, you'll get a new product, you'll get a new element, you'll get a new compound. If the more reactive one is already in the compound, the reaction will not proceed. There will be no reaction. So in this first one, we already said K is more reactive and silver is less. So we're looking to see where the more reactive one is. The potassium is in the compound. If the more reactive one is in the compound, no reaction. There would be no reaction that takes place there because our more reactive one is already where it wants to be and you can't kick it out. Let's take a look at this next one. We have zinc and we have silver. So let's go back to our activity series and find zinc and silver. There's our silver already. There's zinc. So zinc is more reactive than silver. Zinc is more reactive than silver. Come back over here. Zinc is more reactive, silver is less. So again, we look to see where the more reactive one is. The more reactive one is the zinc. It's right there. It's on its own. It's not in the compound. If the more reactive one is on its own, the reaction happens. The reaction proceeds. So the zinc and the silver trade places. So the silver is going to be by itself. Now for the formula for zinc and nitrate. Zinc is a predictable transition metal. It's always a +2. Nitrate, one of our polyatomic ions, is a -1. 2 goes there, 1 goes there. ZnNO3 2 is the formula. Didn't leave myself much room. But that's it. That's how it works.